Hello friends, welcome back to the bench. Our patients are these four boards. The majority probably just needing a CPU socket replacement. But first, let's take a look at each one of them and assess. Also, what we have here are the sockets. And let's hope there are some CPUs, because I don't have that kind of CPU. This is 1200. Okay, so we can fix that other board that is waiting for 1200 socket. So these are probably all 1200s. And these are not. And these are, yes, AM5 sockets. And we have 4 of these. Oh, what is this? Looks like it was melted. Oh no, it was probably just cut off because the tray was larger. Okay, so we have 4 AM5 sockets and 3 1200 sockets. All right. As long as this is the only thing wrong with the board, this should be pretty basic. Our first patient. So let's do quick measurements. Let's go into diode mode. The socket you can already see, or you will see in a second. There. So the socket is obviously damaged. Probably some of these could be straightened out, I would guess. But even if we straighten them out, they still need the replacement. So maybe first let's check the voltage on the battery. We had 3.054. That's enough for the board to boot. Some boards will not boot with dead battery. Don't ask me why. It's just based on experience. Now, let's see. My cheat sheet is in the way. Let's check 5 volts. Fine. 3.3. Fine. And 12. Fine. Or at least no shorts. V-core is fine. Or at least doesn't seem like there are any. Oh, it's not fine. Okay, we have short on V-core. GT is okay. SA is short. No, this is SA. SA is fine. So it's only V-core. Dead short on V-core. Okay, so this is socket replacement and dead short on V-core. And now the question is, with these, because typically you don't necessarily need a board viewer schematic to figure out the board, but there are exceptions, and I have one board over here that there's no short on V-core, but the V-core doesn't go up, and I suspect that it's the CPU that is not compatible with the board, and that's why it's not turning on V-core, and the memory is not visible, but the memory is not going to be visible if there is no CPU ID. So until, or at least on that board. So maybe that's the issue. But there are no transistors like we typically see on V-core, but instead some dedicated modules, which I cannot find. And I have no board view, no schematic, and no idea what this little dedicated output stage is for, or what the pinout is, how it works, nothing. for that reason, I just can't diagnose it, right? So sometimes no board view means you can't really figure out what's wrong with the board. Now on this one, we have, we don't know if we have transistors or not. So let's just confirm, because if we don't have transistors, then we do need the board view for the board. If these are transistors, then we just need to replace them. Because on vCore, the only thing that will short out will be the output stage, because there's not much else than that. Let's use this guy, and let's take off one of the heat sinks. Screw number 1 and screw number 2. Looks like driver chip is on the other side of the board, on the front side, which is good. On some boards, the driver chips are on the other side. Okay, and we have transistors. Very good. Now let's see, are we gonna see some scorched ones? That will make it immediately obvious. No. This one kind of looks like it's been overheated. But no, visually I don't see which one would be the culprit. And there's no point in measuring across them over here, because they're all bridged. They're all gonna show shorted. But our driver chips are these. This is SA, which is fine, or at least no short. And we have short on all of these. Every single one. And all of these two. Right, that's vCore. 6, 8. Yeah, 8 coils. So that rail is shorted, but what we're gonna do is just inject voltage and see what's getting hot. But that's not always reliable, especially in the last one we had with liquid damage. The transistor that was showing on the thermal image was not the one that was shorted. The other one that was not showing up on the camera was shorted. And the main reason for that is if the resistance of the component is low, then it's not gonna dissipate a lot of heat. However, the components that do protect it, like maybe a resistor, stuff like that, that will be heating up. So that might send you on the wild goose chase sometimes. The other solution, or the other way to do it, would be to desolder the coils. That way we would disconnect the bridge on the output, and that might reveal the set of transistors that would be responsible. Not necessarily a single transistor that will be responsible, but at least how many we have. I already put it back, but I think, yeah, basically it'll show you one line that on this line there is an issue. Now let's see the rest. We have a little bit of something over here. What is this? Is that just some... I think this is fine. I think this is just like maybe a silicon, the thermal conductive paste. That's not damage to the board. Yeah, it's just dirty. So this should be fine. And let's check PCI Express. Also looking good. Now important, other than the slot itself, to check any potential damage to those components over here, because that happens when you try to plug in the card, which is pretty big. You can barely see on the other side. It's not that uncommon to just kind of smash one of these caps while trying to do so. Okay, so this one, let's get a sticky note. Where are my sticky notes? So we have one board down. The V-core short should be easy to relieve. I should be able to match the transistors from other boards. We just have to find out if these are N-channel or P-channel, but it's very uncommon to have P-channel transistors on this. It's usually N-channel, but sometimes you have both. You have N-channel for the high transistor and P-channel for the low transistor. It happens. Okay, that was it. Yeah. All right, next one. We're just gonna quickly diagnose all of them, and then we'll pick one of them to work on. Whichever one is the easiest repair, I guess. We'll start with that one. But looks like every single one requires a socket replacement, so. Okay, this one has an on button. Oh, it's a nice one. Look at this. So we have an on button right here, and we have a postcard. Look at the number of coils. We have 8 power connections here. So this can pull pretty serious CPUs, and you can tell by the weight of the board. The socket is 1200 and it is broken. Yeah, but let's see electrically. So again, ground and 3. Fine. Very high on 3. Usually it's lower on 3. 12 volts. Oh. We are open on 12. No, this one's fine. Oh, that's negative 12, yeah. So looks like negative 12 is open. But negative 12 open doesn't mean there's something wrong with the board. Negative 12 volts could technically be unutilized if the board doesn't need it. 5 volts, no, 12 volts is fine. Standby fine. And 5 volts. 5 volts here. It's fine. Now the V core over here seems fine, but let's check on the coils. That is low. That is low, but no short. GT is open. No, GT is not open. SA is fine. And where's the IO? This is kind of different. Oh, here under the M.2, that's IO. And IO is open. Nope, IO is fine. And 0.5. See, now that the caps have charged, now it's showing nice values. Okay, so nothing electrically wrong as far as the initial testing. Then this is so heavy because we have additional metal over here. I don't know if that's aluminum for additional heat dissipation or protective. I don't know. It's very heavy board. So looks like this is just socket. I should have a clamp for 1200, I do believe. This is for 1151, I think. So I should have a socket, but even if not, then I'll just probably replace it and ship it back. I don't see any other damages. Very nice board. This is Z590 Master. Next one is B650 plus Wi-Fi. I love these ones with Wi-Fi. The reason I like them is because all you have to do is connect the antenna over here and you have Wi-Fi. No need to install anything on the board or USB or anything like that. This is also pretty serious heat sinking here, but we have only 8-pin connector and 4-pin connector, so again, that still is decent. It can pull a pretty serious CPU. We have slight damage to the AM5 socket, so this is definitely for replacement. I don't see any other issues, so I forgot to check the battery on the previous one, but that's fine. 3028, again, the battery needs the replacement, but it's fine. And 3.3 is fine. Come on, stay there, buddy. Stay there. 12 volts is open. 12 volts is open. Not too bad. There might be a fuse somewhere, or 1 ohm resistor, or something like that. But that means if the fuse is blown, there is a short on the other side. So the fuse replacement will not help here. Let's check. I checked the 3. Let's check 5. 5 is fine. It's only the 12 volts. Oh, and now it works? What's wrong here? Okay. I don't know what was the... Oh no, this is 3.3, that's why. Oh, and now 12 volts. Again, now 12 volts is fine. Okay, so that was the error of measurement. Let's check V-core input. Fine. V-core on the coils. It's fine. No shorts. GT. Fine. SA. Fine. IO. Fine. Let's check one more here. Yeah. Okay, electrically fine. Or at least as far as the multimeter measurements go. So this is just socket. This is only a socket replacement, very good. AM5. I have not replaced AM5 sockets yet. They look bigger. So we'll see how that goes. If my nozzle is big enough to handle these. And B650 Lightning. Decent. So we have two 8-pin connectors for CPU. So pretty powerful CPUs that we can install here. Battery is fine. I always check the battery because sometimes the boards come in and there's nothing else wrong with them except the dead battery. In some cases they just won't boot. I don't know what this is. It's probably I/O, maybe SA. This is definitely vCore. Everything's really, really low. Really, really low. That's not normal. Yeah, this is not normal. Or at least not on the boards that I'm used to working on. Let's check 12 volts. Fine. 3.3. Fine. 5. Fine. So it's very low on vCore. Now, why would that be? There's a protector on the CPU, which means the CPU socket is fine. Well, almost. There's a slight damage, but not huge. Would that be the reason for the low reading? Maybe those pins are touching, and the pins don't seem to be touching. Or maybe they are. This is definitely broken. The pins are broken. Oh no, this one's fine. This one's not broken. But this one's broken, missing. So either way, we have to replace the socket. So that protector was not really needed on it. So probably someone already tried to bend this in position, and that's when it broke. Or the pin is still somewhere on the board, causing short somewhere. But let's measure again. Yeah, it's really low. It's not supposed to be that low. Yeah, and it should be growing. So there's something wrong on vCore. Unless this is supposed to be that way, but I don't think so. Now let's check with the resistance. Yeah. Oh, now it's growing. 100 ohms. Roughly 100 ohms. That is low, because it's stable 100 ohms, right? It did go up, so it started from lower. So we know the capacitance is there and it's charging, but that's not what we would expect. Let's check here. All right, it's going from 25 to roughly 100 ohms. So we have capacitance on the output, 99.7. That's the magic number. I have not seen the board that would have, without the CPU obviously, because once you place the CPU, then the resistance is basically the resistance of the CPU. But when it's not connected, the resistance should be a lot higher. And since the socket is not damaged that much, I expect that this pin that is missing is either ground or vCore, something non-essential, or maybe something redundant, something with high redundancy, so it wouldn't cause the board not to boot, but this low resistance definitely would. It's not going to be shorted cap because that would show as a dead short. The only reason we would have low resistance like that is either one of the transistors have changed into the resistor, or the control chip is faulty. But definitely there is something funky on the vCore here. And that's how I'm gonna mark it. This one will be a tricky one. Actually, all of them will be tricky ones because I don't have a CPU to test it with. So all I can do is just replace the socket the best I can and ship it back, pretty much. And actually, there one thing I haven't checked on either of them is the memory. That's fine. Fine. And oh, where's the memory coil? That's different architecture here. So usually memory coil is located next to the memory on the right over here. But I'm guessing one of these under the memory over here above the PCH, that must be the one. And the BIOS on it appears to be okay. The BIOS chip is SMD. That kind of sucks because to do the BIOS on this one we have to desolder the chip. This guy. So just like on laptops. And this is BIOS A1 and BIOS WSON A1. So it's, I assume it's this one. Yeah. So this one we can clip onto. Although, well, we could clip onto if it wasn't for these components next to it. So in either case, to do the BIOS on this one, we have to either desolder the chip or hook onto these pins over here. This is this says SPI TPM J1. So maybe this isn't going to the BIOS, it's going to TPM. Could be. But usually next to the BIOS you have these pins, and you can just find the MISO, MOSI, clock, and CS pin, and just connect it. Which connect directly to the chip, because those chips work on SPI. Okay, so this one will be tricky. Low vCore. Because you see, the short, it's relatively easy to find because it's a short. So you can do it, either inject the voltage, see what's getting hot, or just start removing the components, or inject the voltage, and if you don't have the thermal camera, swipe it with some alcohol, see which one evaporates fast, or just feel with your finger, because if you inject say 2 volts, that's going to be a lot of heat. You're going to detect it with your finger, and since there's a short, then you don't risk damaging anything, even if, because vCore normally is below 2 volts, like around 1 volt, even lower, depending on the usage. But with low resistance, well, on 100 ohms I would have to inject I would have to inject quite a few volts, and that poses the risk to the board, and we can fry something up with higher voltage. And even if we inject the voltage and we spot something getting hot, that doesn't mean that it's actually the culprit. So this one will be a tricky one, especially since on V-Core we have about 14 coils on V-Core. That is definitely the record one. Alrighty, so that's B60. Now let's check the CPU tray. So this is the back of the replacement, and so what I'm looking for, anything that would disqualify this socket. Also, I want to see the kind of solder. Some of these are shiny, some of them are not. And this is lead-free solder. Beautiful. Alright. So this is AM5 socket. And let's take a look at the 1200. Yeah, at least these have fewer pins. So it should be easier, right? But I don't think it makes any difference. Number of pins. It's not like we're soldering them by hand. Yeah, this is the one we're gonna start with, the 1200 socket, because I already have the board prepped. Actually, I do have to clean the few more pins on it before it's ready, but other than that, the board is prepped. So this is the one we're gonna start with. But this is just a quick assessment of how much work we have with this, and looks like it's gonna keep us busy for a little while. Too bad I don't have the CPU to test it with. But what are you gonna do? Alrighty, so stay tuned for the 1200 socket replacement on the other board, and those AM5 boards, which seem to be very powerful. So if we can fix those, that's gonna be... Oh my gosh. Anyways, thank you guys very much for watching. I do appreciate you. And I shall see you in the next one.